Well, folks, last but not least for the evening, I'm going to stick it out for one more. My tape's about to run out. So, video 4, we were just briefly talking about factors and reducing fractions. That's what factors really pertain to in arithmetic. Let's explore very quickly. I'm going to show you some patterns of the digitry of our numerical system, as in 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are all of the numbers you're ever going to have to deal with in math. They may be pitted next to one another and representing, these exorbitant values. But once you can understand the pattern of how these numbers relate to one another, it's going to really make this arithmetic a lot easier for you, especially in the realm of fractions. Let's talk about these. We were talking about factors, as in, let's say, the number 20. What are the factors of the number 20? Well, what of these digits, of course this is a 2 and a 0 next to one another, what of these digits make up 20 by means of multiplication? Well, what gives you 20? 1 and itself, obviously, and that opens up a subject called prime factors. If the only factors of a number are 1 and itself, it's called a prime number. Now, we are not talking, the 20 is not a prime number, obviously, and there's several reasons you can learn to know that. Some other things that give you 20 would be 2 and 10. And I know 2 would go into 20 because 20 is an even number. I also see that it ends in a 0, so I know that 10 will go into it. And I'm going to show you several of these little tips and tricks. We also have 4 and 5 that will multiply together to give you 20. So those are all the factors of 20. And obviously if 20 was part of a fraction and the other part of the fraction had factors, there's a good chance we could reduce that fraction down. We'll talk more about prime numbers and those things in a minute, but I wanted to just kind of expose you to what we're actually talking about here when we're talking about the patterns of these digits. Well, keep in mind, 0 goes out of the picture when you're dealing with fractions. If you have 0 over top of anything, oops, don't want to do any algebra yet, 0 over top of anything, or anything over top of 0, these have no value. So we don't have to really worry about 0 in terms of fractions. If you see a 0 in a fraction, or your calculation comes up to have something to do with a 0, out the door, no value. 1 gives you no help because 1 goes into everything. Now, and I already told you that a prime number, which is going to be very important later on if you want to get fast, and this all, like I said earlier, this all really relates to speed and accuracy. So we're trying to get a little faster and a little more accurate with this stuff. 1 goes into everything, so 1's not going to help you in terms of reducing a fraction. Okay, here's where it gets interesting, because 2 is a very useful number in terms of recognizing the pattern of every number that is a multiple of 2. And it's really easy to spot because if we all know what odd and even numbers are, anything even can be divisible by 2. So if you have any even number, even over even, in a fraction, you can obviously reduce this down because you can send 2 in, or in other words, divide it by 2, or I like to say half it. Let's use the old half it, okay? So what I tell students is, many times this is the case too, when you see a fraction, half each of the top and bottom, half them until you can't half them anymore. I'm actually going to write that out because it's such a useful way to look at this in a very simple way. Half till you can't half no mo. Half till you can't half no mo, okay? What I mean by that is when you see, let's say for instance, 24 40ths. Okay, I would immediately know that these are even numbers, and I can half them to 12 20ths. Still they're even. 6 10ths. Still they're even. 3 5ths. And in this case, I'm done. Now, you're not always done just because you've halved it till it can't be halved anymore. Oftentimes you are, but not always. So be careful. Don't just half it till you can't half no mo and then quit, because it's not necessarily finished being put in its lowest terms. 3/5 in this case is, and because I know that 3 and 5 are both prime numbers, and there's a whole, like I said, bucket of pythons that can be opened up about that, which we'll open up. 3, oh, I want to make mention of this though, but if you can't half it, I mean, if you half it till you can't half it no mo, that takes care of 4 and 8, because those by default will be factored out as you divide something in half continually. Now keep in mind, you'll have to go through some more steps when you're halving till you can't half anymore. And there are math teachers who probably wouldn't agree with my method, but I promise you it does work. And for passing standardized tests like the GED or the graduation exam and things like that, you're going to be just fine doing it my way. We're not getting into some kind of Rain Man speed math. So this is a practical way, and this is the way I do it, and it works for me. So as I always say, get off my back, math snobs. Now 3 is important, because 3 is another identifiable, how can I say this, I'm blank for a word to use. It's an identifiable factor, very identifiable factor, because there's a pattern to all the multiples of 3, and I want to illustrate this now, and many of you may know this, some of you may not. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, and we'll just stop there. That's enough. They go on, obviously, for infinity. These are all multiples of 3. Well, look at this pattern. I don't know if you've ever noticed this before. If you add the digits up sideways, look what happens when you get into these double-digit and even triple and quadruple-digit numbers later on. 2 plus 1 is 3. 5 plus 1 is 6. 8 plus 1 is 9. 2 plus 1 is 3. 4 plus 2 is 6. 7 plus 2 is 9. 3 and 0 is 3. 3 and 3 is 6. 6 and 3 is 9. 3 and 9 are 12. And 2 and 1 is 3. If you'll notice, if you continue to add double-digit and triple-digit numbers up until you end up with a single-digit number, you're always going to get 3, 9, or 6 if it's a multiple of 3. What does that mean for your fraction reducing strife? Well, it means that if you see a number, if you have a number, let's say you have, let's say something over 5,172, which this is a ridiculous example, and anyone who gives you some kind of a fraction that has a denominator of 5,000 and some should be shot. 5,172, but we could see if 3 is divisible into this evenly by adding these digits up. 5 plus 1 is 6, and 7 is 13, and 2 is 15, if we add those up. Well, will 3 go into 15? Well, yeah, it will, because 5 and 1 is 6, and we already know probably that 3 will go into 15. Once we see that, we immediately know that 3 will divide evenly into 5,172. Let's take 3 into it. 3 into 5, 1 time. Let's erase my squiggly. 1 times 3 is 3. We subtract that, we get 2. Bring our 1 down. 3 into 21, 7 times. 3 is 21. 0, 7. I don't want to run out of room on you here. 3 into 7, 2 times. 3 is 6. Subtract that, we get 1. Bring our 2 down. And 3 into 12, 4 times evenly. No remainder. 1,724 is our answer, for that. So that, you can easily identify fractions that have a numerator and denominator that have 3 as a factor, then immediately you can divide 3 out of them. Well, the magic of that is it takes care of 6 and 9. You never have to worry about factoring 6 and 9 out of numerators and denominators of fractions. If you do half it till you can't half it anymore, check your 3's trick, and then these last two are relatively easy. 5 is easily identifiable because it ends in a 5 or a 0. So any fraction that has numbers that end in a 5 or a 0, 5 will divide evenly into them. And that only leaves 7, and I always tell people 7's kind of the bastard in this case, because 7 is a very hard number to deal with in math. It's actually the largest single-digit prime number, which I'm gonna do another video on prime numbers. But this 7, it goes into some really strange numbers that you wouldn't think it would. So there's actually a method I would encourage you to use for reducing fractions. It would go like this. Half it till you can't half it anymore. Check your 3's. Check your 5's. And make sure 7 is not divisible by both numbers in a fraction. And we'll cover this. I'm out of time on this video, but in the next video I may take a minute just to briefly illustrate this quickly so that you can conquer the reduction of fractions very quickly and efficiently and not let it be a stumbling block to your understanding of broader math concepts. Thank you for watching tonight's videos. We'll be back on video 5.